Skinner, one of our longtime members, and Roger is going to show us his technique for segmenting.
Several months ago, am I on? Everything okay? Several months ago, one of the members of the club came over to the house and they wanted to make a bull ring using zebra wood. And I said, well, gee, you'll get some very nice side grain if you cut it into rings. So I said, why don't we take it and make it vertically cut and then save the grain pattern of the vertical cutting. So that's what I'm going to try to show this evening or this afternoon, and we'll pass everything around. I'm going to use, this is the end result of what I made to do this demonstration with. Primarily just the main ring. The bottom and the top ring is standard horizontal, what I'll call horizontal segmentation, just to simply hide the top grain of the vertical side. And that's what this is all about. The reasoning for it, again, is primarily to be able to do segmentation, but to maintain the grain pattern. How about C is equal to pi d? There we go. We got to go back with a little bit of basic algebra. We had a guy come in here from Phoenix, out of the Phoenix Club. Oh, it's been 10 years at least ago. And he tried to explain this using calculus, and I fell asleep. But anyway, I went back and said, well, it's pretty simple. We need to know a basic diameter that we want to start with. I need a diameter of 14 inches, and that's where I started on this one. And the 14 inches basically came from the base because I built the base first. So then I had to build the ring to go with it. But anyway, if we take circumference is equal to pi times d, or the diameter, and that pi, we can use it in a lot of different ways. If you have one of the HP Hewlett-Packard calculators, they have buried within that memory pi out to about 19 or 20 places. We don't need that. We can sand that away in about 5 seconds. What we need is that 3.1416 is plenty close enough for most of the stuff we do in wood. In fact, you could probably use 3.14 and be done with it. It's going to give you close enough to what we do. It depends upon how wide the piece is that you want to use. And I usually start at about 1.25 inches. So I got plenty to have any kind of slop with. If I make a mistake or it doesn't line up or something or other. If you like to get real dangerous and live real dangerous, you can go down to 1 inch, 3/4, whatever. But you're just taking everything because you've got to be able to keep it together. But anyway, out of that, we decided that the diameter was. We take that, multiply it by pi, and we end up with the circumference. The circumference then is going to be used by taking the number of pieces that we want. In this case, for this bowl right here, I used 20 pieces. And I'll explain to you why I used 20 pieces in just a second. But anyway, 20 into that circumference, whatever it was, comes up and then gives us the long axis of the. Or you want to go and play a little bit, you can actually on that inside edge if you want to or need to for some reason, but it's the same idea. But anyway, from that, we can then take the number of pieces and divide it into 180. 180 comes from an equation that talks about that angle and 360 divided by 2 times the number of pieces. If you do the 2 into the 360, you get the 180. And so this then gives us that angle. In my particular case with this ring, I used 20 pieces, divide that into 180, and I 9 degrees. 9 degrees or 10 degrees or 12 degrees or 15 degrees or 20 degrees or 30 or whatever is pretty easily hit on most of the chop saws. And on most of the table saws, you can set to those angles and hit them pretty consistently. when you start trying to hit 16 and a half or 16 and a quarter or 11 and a quarter, then we're really starting to get, well, maybe it's there, maybe it's not. And you better make a whole bunch of scrap pieces just to find out. If you stay with the solid full angles, most of the saws will hit it without a whole lot of trouble. Anyway, that gets us to that point. We now have, in my case on here, I took a piece of Babinga. It was about 6 inches wide and about 2 feet long. I got 2 strips out of that. And the first cut was to cut the angle, that 9-degree cut on the outside edge. I then took that dimension, that X dimension that we needed, and set my saw so that I could cut the second angle. That then gave me the third angle or the first angle for the second piece. Did it again and got got the ring. The ring itself, I dry put them all together. Every time I build one of these types of segmentation, I put it together dry so that I can see what all the joints are doing, make sure that they're all the way we need them and want them. If I had an error in there someplace, then I'd have to figure out, well, where did it come from and how do I fix it? And a lot of times it's a matter of chuck it and start all over again, but hopefully not always. What I ended up doing in this particular case, because this thing is about 3 inches high, I ended up using 2 clamps. The clamps themselves are band clamp, and they should be going around. There should be a little handout passed around that I finally found a company out of Amazon that make these things, and they start out at about 6 or 7 inches long, and they'll make one for you out to 63 inches. And you can actually buy the material in, I think it's 50 feet of material, and you can get the clamps, but they're not these types. One of the advantages of this particular type of clamp is that I can adjust it to around the pieces of wood and pull it in, clamp it down, and then tighten it up. So in other words, if I buy this clamp, I forget how long this one is, but anyway, if I buy this clamp, I can use it for anything really all the way down to something like 2.5 inches or so. So they come 10 to a pack, and the prices that I've seen on them are relatively reasonable. 10 for less than $30 is pretty reasonable for these. But depending upon the height of it, I like to use more than one clamp. Multiple years ago, I made a barrel like this, and I only used one clamp, and I put it on basically the bottom. After I got it all done and so forth, I had it sitting in the house, and those pieces on our angle. And okay, how'd that happen? And why did it happen? I don't know, but it did. But sat around for a while, probably went in the fireplace. But anyway, that's where we are. So a lot of people get really excited about this mathematically and begin to get afraid of trying to do it because of the mathematics. As you saw, it's only a couple of equations, and it's your plain old 4-banger calculators will do a real fine job. Your telephones will do it without any trouble at all, and you can almost do it in your head to get most of the mathematics done. So don't be afraid of it, type of thing. And the same equations hold true for what we'll call the horizontal, the rings, or the vertical. The same equations hold true. The biggest problem is going to be setting your saw. And most of the chop saws, most of them, are stable enough that you can set it to an angle and you can produce the rings. The table saws, of course, we can get them just the way we want them. We should have another ring. Picture of the ring. Okay, next one after that. There. Oh, next. Okay, the band clamps, Cambridge quick release clamps. I went to Amazon and then asked for clamps, and came up with a few dozen clamps of different kinds and finally narrowed it down to this. But they're made out of stainless steel, and the biggest problem with them is that when you put them on the ring, the glue gets into the clamps, and you say, "Oh nuts! Now what?" I've tried to soak them in hot water with simple green and everything else to get the glue out. It doesn't want to come out. So buy 10 of them, use 2 or 3, and use 2 or 3, and use 2 or 3, and you go buy some more kind of deal. So keep them in business. What we're trying to do, next slide. What I'm trying to do is hide that grain pattern that you would get out of the joint. If you look at that oak bowl that's going around, you can definitely see the joint. That's because of the wood. If you were to look real close at this babinga, you have a real hard time seeing the joint in there, and that's the whole game here. If we go back to the zebra piece of wood that we started out with, the zebra itself has got a beautiful grain on the flat cut. And if we start going to the edges, we'll end up with a relatively not very nice grain pattern to it. Yes, sir. Next slide, please. Okay, after we get the ring itself built, now we need to figure out how we can get rid of all the corners and how we can hang on to it for turning purposes. The jumbo jaws, there are problems with them. I think that a ring this size, though, I can get at least 3 to 3.5 of the 4 jaws to bound pretty good, get me a pretty good clamp on there. The gripper post, this is a set of 3-inch grippers. They tend to hold real well. I don't advocate the idea of going down to fewer than the 8. If you can get more than that in there, well, you're that much better off. But anyway, we'll do the outside of it. And then what I end up doing, for lack of anything else, what I end up doing is making a mark, say between the joint of two of the jaws. Make a mark there, or remember where it is, and then make a mark on the ring. But when we turn it over, we can come back to that same place. Your clamps, your grippers are going to sitting basically at the same place within the ring. What happened here, I did the outside first, got the outside pretty round, turned it over, got the rest of it, and then took it off and moved the gripper so that I could grab the outside and turn the inside. I had already made the base, and so what we're doing now is trying to figure out a way to marry the base with the ring, and that's the next step of the process. I've turned the outside. I turned down to about 3/4 of an inch, 1/2 inch. Then I turned it over and did the rest of it. Now what that does, so you run into the chance of you run into the chance of the same diameter. What you have to do, as I explained, was the mark so that you go back and the grippers will grab basically the same places, and that's the key to it. I'm in a joint, so you really need to just kind of a solid surface all the way around with all the 8 grippers. 8 doesn't divide into 12 or 20 very nicely. So it's the problem. Okay. All right. Now, after we get the bottom turned, and in this particular case, the bottom, it got turned separately or made separately. And then, I don't know if you can, I doubt that you can see it. Right there's a real small, lay it flat, you got it. Anyway, right there is a real small little hole. It's really just a dimple. That fits into it. Can you see it? That's a wire nail. What I ended up doing was, and this is, some of you guys have probably done it many, many times more than I have. But anyway, back in about 1953, my shop teacher told me how to do this. Piece of pine, don't get the most expensive piece you can find. Run it through a planer or a sander on one side. That's going to be the side that's going to go down to this supposedly flat surface. Use it as a square, 5 3/8, 5 3/8. This is square. When I originally started out with this, there's a joint right through the middle of the bottom here, and that's going to be one of the centers. The other one is this piece right here divided by 2, this piece divided by 2, and a straight line drawn through there, a line drawn across. That gives us points to put the 4 corners with the flat edge down to the board, to the bottom of the bowl. Put a little bit of glue on the surface. Put a blue paper towel in there. Put a little bit of glue on the top of the blue paper towel. A little glue on here, and take your nail. I'll pass this around just to show you, but anyway, put it in the hole at center and put it in the little dimple that's down there in the bottom of the bowl. Line the 4 corners of the square up with the 2 lines, and you've got this on here centered. Now put your faceplate on, and this is just happens to be a 4-inch faceplate for my lathe. You can buy these things, and I bought a set of these for $1.50. If I had a block of maple, I could make my own. Anyway, because that's all it is, an inch diameter for mine. It fits inside the base of the faceplate, and that pin could be a nail, and drop it down so that it comes back into that hole that's already centered up, and I'm centered. Said that I use blue paper towel on here. That's, people have used newspaper. Paper towel works fine. There was an article written in one of the turning magazines, I don't know, years ago, where a guy took the gloss paper that you get in catalogs and that kind of place and tried that. Works fine. The whole idea behind it is that we need to have something in between the wood and the wood so that we can get it to come loose. Now, getting it to come loose should be the next picture. Now, what I found out when I bought that particular piece of pine, don't get the most expensive pine that you can find, number one. Number two is that most generally, once you start getting out in these 1x6, 1x8 dimensions kind of thing, then chances are relatively good it'll have a nice cup to it, nice bow to it. So when I said that I sanded one side to that, I'll explain in just a minute why I did that. But that's the block with the nail. We'll go from there. Now this is after the piece has been taken off. You can kind of see in that picture the square was on there. That's the blue paper towel, and we're going to get rid of that and starting in the next slide. Okay, there's a real bad picture, and I'm sorry about that. But anyway, that's, if you look real close, you can see the pencil marks, and you can see that there was a little dimple right there, and it didn't go away. It's still there. Doggone it. But anyway, I should have sanded that a little bit more. But anyway, it's there. That nail, the tip of that nail will fit into that hole, and that lines us up. And that's the key to this. If we were off 1/4 of an inch, 1/8 of an inch, You'll know it as soon as you put that piece on the lathe. And you've got the ring already made, and we want this to fit to that ring. So we've got to be pretty accurate in it. And that's why I keep talking about the idea on these angles. Once we set the saws and set everything to cut the angles, a quarter of a degree on one or two pieces, you're going to see it in the glue up. It jumps out at you after a while. All right, here's where the fun part of this whole thing comes about. And this is really the scary. I love to scare people when I do this. My shop teacher scared me, so I might as well scare him. Anyway, I want to back up one, just leave the slide on. I want to back up one step though. When I glued the scrap block onto the bottom, I took the whole assembly. I had already put the ring onto the bottom. And what I ended up doing was I ran it through my surface sand, and I sanded this top surface of the scrap block so that it was flat to this surface. That makes sense? In other words, we want parallel between this flat of the scrap block and this flat of the ring. So the whole thing is parallel from here to here. And if I took the whole thing and ran it through my sander, then I would achieve that. Okay, so now I get a hold of this. I'm done turning on it. I've probably got maybe 5, 6, 8 coats of finish on it. It's out to sanded out to 1,000 grit. It's pretty well finished, except for the fact that I got that block. I don't want that on there with this Babinga. So now how are we going to get rid of that? But what I end up doing, but not 1953, my teacher showed me how to do this. I end up putting it up against, I take the end grain of the scrap block. I'm looking at it right straight up and down, and I take my chisel and I'm leaning up against it, and the table's sliding, so I can't push on it very hard. But anyway, I'm holding it on there. I take the chisel and put it right where I want it, and bang. Next slide. You should be able to see a first, yeah, you can see a first split, and a little bit of it will come off. I move, bang, half-inch, bang. Pretty soon we put the whole thing laying in a pile on the table. That's why I call it scrap. It's not expensive wood. It's pine, El Cheapo pine. But anyway, we chisel it off. You should have it. Another slide. Yeah. Okay. Now that the base is off, the scrap block is off, the blue paper towel and the excess glue that we had down in there, it's got to get sanded off. Palm sander, 100 grit, takes it down, brings it down. You can take the whole thing now, put it back onto the jumbo jaws, put it back onto the lathe, and take that area down to whatever you want to stop at, 1,200, 3,000, whatever, and then start putting finish on there. So we need about the same amount of finish on that part of it, the bottom part of it, as we have on the whole thing. Got to remember now that we have, the only way we can hold on to it now is with the jumbo jaws and the grippers. So we better be pretty well finished with it. But next slide should be, okay, this is the whole thing, and on the bottom, it's still on the lathe, and I've got the jumbo jaws hanging onto it. I'll finish out the bottom and bring it out to 5 or 6, 8 coats of type of Minwag. Next slide. This is the side view of it. What I did on this case is we've got the end grain on the outside on the main ring, and now we need to hide that grain. So we'll make a regular standard ring and place it on and put it on there and hold it there. The bottom, the base is showing through as it does. There's the maple, Paduic, Purple Heart, Wingay, and white oak on the outside edges on the bottom. I talked to Gene about making another class to show you how to make that bottom, but it, oh, next slide. Okay, that's the inside. Next picture. Okay. Now, I'm not going to pass this around because it's a little bit heavy. But anyway, 458 pieces in that. The base for the bishop if he ever decides to retire, or if the rest of the church lets him retire. This was done with the same idea in the center, this main center ring here. That's where I started. I made that, and it actually started out at about a 5 or 5.5 foot glued together. The Purple Heart and the maple and the Wingay and the Paduac on the outside edges. Then that got chopped up, put back together. It got cut at 30-degree angles and then put back together. And then it got cut again to make the section. That was all clamped together, allowed to dry. And then I went down on the bottom, the base, the actual piece of alder that's on the bottom, and started coming up the walnut ring in here and this main ring to marry together. Once we got this much of it, then going easy because these just had to be a little bit smaller in diameter. But this had to be was the matching surface. It had to be there. If you want to read what it all signifies, you're more than welcome. But it starts out at the bottom with a piece of alder and myrtle is on the bottom and comes up from there. And it just presents God, and then Adam and Eve, and Abraham and Sarah, and then the 12 tribes of Israel, the 39 books of the Old Testament. And this represents the 400 years of captivity. And then we've got Mary and Joseph and Christ, and then the 12 disciples and 27 books of the New Testament. And then the lid itself represents the women of the Bible, and there's multitudes of those. But then the finial itself represents the Trinity of the Bible.
The question is, how did you come up with the idea of a story in your vessel?
The first one that I made, this is actually about the fourth one I made. But the first one was a gift to the district superintendent who moved out to one of the churches in the West Valley. He and I became friends. I'm a certified lay minister within the Methodist Church. And through a lot of my studies and a lot of reading and a lot of classes that I teach, I've learned where all that, basically a lot of that came from. Most of it's out of the Old Testament, out of the Bible, and it's there. There's more that is left out of this than there was put into it. And I've always looked at it on the idea that God makes the trees for us, and then he gives me a little bit of capability so I can make something for him. That's my story, and I'm sticking to it.
Thank you. I think part of the answer is you need to be creative. Come up with a story for your object. Nobody's going to question you about it. It's your story.